Hello, in this video, I will explain to you on how to find PO here using mesh analysis. So our goal is to find PO. Our goal is to find PO. However, we need to use mesh analysis. Okay, mesh analysis. Let's do it step by step. The first step that we need to do is to label all the nodes. I mean, label all the loops. All the mesh or the loops, right? Okay, let's see what can we get from here. I usually draw the loops clockwise like this because I am right-handed, right? Because drawing clockwise is more easy. So I will name this as I1. And then I will name this here as loop I2. And here I will also name this as I3. It's completely logical, right? I1, I2, and I3. Okay. And then let's extract some information that we can get from the circuit here. Here, we have a current source, which is the only current that passed through this branch here is I1. That means that I1 and 0.5 ampere is the same. So we know exactly the value of I1 here. I1 is 0.5 ampere. Good, because we get one value here. We only need to do KVL at these loops here. So the second step is to do KVL for all unknown loops, right? Unknown loops. And we already know I1 here. I1 is 0.5. So we need to do KVL at loop I2 and KVL at loop I3. Okay, let's start from I2 first. Let's do KVL at loop I2. Okay, what does KVL say? KVL said that the sum of the voltage in a loop will equal to 0. Good. Now, let's start from this 40 ohm resistor. So I will have 40 ohm there. But remember, we need voltage. To get voltage from resistance, we need to multiply it by the current, right? But here, we work on I2. So I2 always came first. So I will have 40 multiplied by I2, right? But here, I1 is flowing to the opposite direction. So I will have minus I1. Okay. However, we know exactly what is the value of I1. We can just plug that in, right? Because I1 is 0.5 ampere. So I will have 0.5 here. Okay, let's move on to this 12-volt voltage source. And because our current flowing clockwise, the current here will enter from the negative terminal. So I will have negative sign here, right? And the value is 12 volt. We already have the voltage, so we don't need to do anything here. So minus 12. Good. And now let's move on to this 100 ohm resistor. So I will have plus 100. And remember, this is resistance. We need to multiply it by the current. But we are working on I2, so I2 came first. I will have I2 here. Good. And then minus here I3 flowing to the opposite direction. So I have I3. And I think we have finished because we have three components, right? 1, 2, 3, and we have three terms. 1, 2, 3. And all of that will equal to 0. Good. Now what can we do? We distribute all of the brackets here. So I will have 40 I2 and then minus 20 minus 12. And then plus 100 I2, and then minus 100 I3. Okay, all of that will equal to 0. And so we will have 140 I2, and then minus 100 I3, and that will equal to 32, right? Let's have this as equation number 1. And we still need to do KVL at loop I3, right? So let's do exactly that. Let's do KVL at loop I3. Okay, I think I need to resize that line there so I have some rooms here. Okay, this looks good. And KVL said that the sum of the voltage in a loop will equal to 0. Good. Okay, let's see here. So we will have 100 ohm here, but we need the voltage. So we multiply this resistance by the current. But currently, we are working on I3. So I3 came first, right? So we will have I3 first. But then here, I2 flowing to the opposite direction. So I have minus I2, right? Good. And now let's move on to this 150 ohm. And the only current that passed through it is I3. Good. And I also have this 50 ohm, so we will have 50 multiplied by I3. And then we have done all for these loops, right? So all of that will equal to 0. Good. Now what can we do? We distribute this 100. So we'll have 100 I3 minus 100 I2. And then plus 150 plus 50, that will be 200. I3, and all of that will equal to 0. And then we will have minus 100 I2 plus 300 I3. Okay, and that will equal to 0. And let's have this as equation number 2. Good. Now we have two equations with two variables, right? We should be able to solve them. Okay, maybe let's clean up our slide and solve the equations. Okay, now we need to solve the equation, right? Which is the third step of our analysis. Solve the equation. Okay, we have these two equations, and I think I will do elimination here by multiplying this by 3. And this multiplied by 1. Okay. 140 multiplied by 3, that will be 420 of I2. And then minus 300 I3. And then I will have 96, I think, here. Okay. And then we will have minus 100 I2. And then plus 300 I3, right? So 300 I3, and all of that will equal to 0. Good. Now, what can we get from here? I will have minus, no, not minus, 420 minus 100 is 320. 320 of I2. But I3 here will cancel each other, and so I will have 96 here. And so I will have I2 here is equal to 96 divided by 320. Okay, and I think that will be, let's divide this by 32, right? So I will have 3 over 10. Yeah. So I will have 0.3 ampere. Okay. But then that is I2 here. So let's have I2 here. I2 is equal to 0.3 ampere. But then we need to find out what is I2, right? What is I2? Let's plug this into this, right? So I will have minus 100 I2 plus 300 multiplied by 0.3. And that will equal to 0. So I will have minus 100 I2 plus 90 is equal to 0, or 100 I2 is equal to 90. Therefore, I will have I2 here is equal to 90 over 100, or that will be 0.9. The unit here will be in ampere. Okay. Oh no, I made a mistake here. Yeah, I made a mistake. So let's repeat that. So I2 is 0.3. So I'll have minus 100 multiplied by 0.3 plus 300 I3. That will equal to 0. Good. I'll have minus 30 plus 300 I3 is equal to 0, or 300 I3 is equal to 30, right? And so we will have I3 here. Let's divide both sides by 300. We will have I3 is equal to 0.1. Yeah, 0.1. 0.1 ampere. Okay, so now we have I3 is equal to 0.1 ampere. Good. Now we have all the values needed here, I1, I2, and I3. However, the question does not ask about I1, I2, or I3, but we need to find out PO, which is the last step of our analysis, which is answer the question. Okay, maybe let's clean up our slide first. Okay, how to find PO, which is our final goal. PO here is equal to, because the current should goes from the positive side to the negative side, it should be like this here, right? And the one that have the same direction as this is I2, so the positive one will be I2. And here I3 flowing to the opposite direction, right? I3 flowing up, so I'll have minus I3. And that is this current here that pass to 100 ohm resistor. But then we need voltage, so we multiply it by the resistance. So I will have 100. And we know I2 and we know I3, right? So we will have 0.3 minus 0.1. And we can multiply it by 100. 0.3 minus 0.1 is 0.2. And then multiply it by 100. And so we will have final value of PO that will be 0.2 multiplied by 100. It is 24. Okay, let's put this into a box. So this is our conclusion, which is PO is equal to 24. Okay, and we have achieved our goal, which is PO, which is 24. Okay, I think that's all for this video. Thank you for watching. See you in the next video. Bye bye.